In this lesson, we'll increase our ability to communicate data between custom functions and a main program through the use of what we call fruitful functions. As a practice problem, we'll work on an algorithm that translates numbers from decimal to binary or base 2, as we leverage a fruitful function to pack this functionality. I'll conclude with some remarks about the lifetime of variables within and across function, what we call the scope of a variable. Let's get started. We've studied how Python allows us to group a sequence of statements, pack them under a function definition, and later invoke it from the main program. But what if that main program not only wants to pass input arguments to that function, but also needs to obtain some output value calculated within the function body? Well, that's exactly what a fruitful function does. We say that a function is fruitful when it provides a return value of any type to its caller, whether it's another function or the main program itself. And we've seen some examples of this before. Look at this familiar line of code. Here, function input waits for the user to enter text and returns it as an output value, which is captured in the variable on the left of the assignment. We say that the input function is a fruitful function because it returns a value to its caller. Another example is the sqrt function in the math module. The function returns the square root of the value passed in its argument, which we may again capture in a variable on the left of an assignment. The sqrt function is also a fruitful function. Now, how can we make our own functions return values? We can do that through the use of a return statement. A return statement may appear anywhere within the body of a function, but we'll typically find it at the end, as shown here. In this code structure, we see the function header, a sequence of statements in the body of the function, and one last statement containing the return keyword, followed by a value meant to act as the result of the function. Later, you may call your fruitful function from your main program, or from the body of any other function for that matter, and capture the return value in a variable of your choice, as shown here. Let's look at a specific example. Here, we're going to define a function called isDivisible that takes two input arguments called x and y. The purpose of this function is determining whether x is divisible by y, and in that case, return a Boolean value set to true. Otherwise, the function should return false. Here's the body of the function. Determining whether one value is divisible by another can be done programmatically through the modulo operation, which, remember, calculates the remainder of an integer division. If dividing x by y gives us a remainder equal to 0, it means that x is divisible by y, in which case we return true. Otherwise, we return false. But this code is actually rather redundant. Notice that expression x modulo y double equal 0 is already a Boolean expression, providing a result set to true or false as a condition to the if-else block. We may omit that if-else block altogether and instead return the result of that Boolean expression directly, as shown here. If x modulo y double equals 0 is true, the function returns true. And if that same condition is false, the function returns false. In other words, the function returns the result of the condition itself. Let's look at some possible invocations to this function in a main program. This call checks whether 10 is divisible by 5. The function returns true, which is saved in variable divisible. And then the print call shows this value in the terminal. Next, we check if 10 is divisible by 4, and in this case, the answer is false. Since function isDivisible returns a Boolean value, it can be called directly in the condition part of an if block, or even in a while loop. Here, we're calling the function in the condition of this if-else block to determine whether 6 is divisible by 2. If so, we print yes, and otherwise we print no. Since the condition is true, this code prints yes into the terminal. Let's look at another example. Suppose you want to design a function that calculates the area of a rectangle given the coordinates of two of its opposite corners in a two-dimensional space. Consider, for example, points 6, 4, and 1, 2, and the rectangle resulting from connecting the horizontal and vertical lines traversing these points, as shown here. You may express the area of this rectangle as the difference between the x-coordinates of these 2 points, 6 minus 1, times the difference between their y-coordinates, 5 minus 2. The final result is 10. To account for the fact that the first and second point may be given in any order, we must calculate the absolute value of the distances so that the final area is guaranteed to be a positive number. For example, consider now points 3, 3 and 7, 1, and the rectangle formed by the 4 lines traversing these points horizontally and vertically. We calculate the area as the absolute value of 3 minus 7 times the absolute value of 3 minus 1. The result is 8. Let's write the Python function for this. We call this function getRectangleArea. The function takes 4 arguments called x1, y1, x2, and y2, representing the x and y coordinates of the first and second points, respectively. In our first block of code, we calculate the absolute value of the differences for the x and y coordinates and save the resulting distances in variables dx and dy. Then we calculate the area as the product of the distances and use a return statement to provide this value as the function's result. In our main program, we can test the behavior of this function by calling it with the coordinates of the 2 points representing the rectangle. Instead of saving the return value in a variable, we'll simply pass it as an argument to function print, so that it gets printed directly into the terminal. The first call uses the coordinates of the 2 points for the first rectangle shown earlier, 6, 4 and 1, 2, and passes them as the function arguments. The return value is then passed directly into the print function, which prints value 10 into the terminal. We then do the same thing with the coordinates of the 2 points of the second rectangle shown earlier, 3, 3 and 7, 1. The printed area in this case is 8. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you and happy coding!